We are and we have designed wirelessly enabled medical dispensing system. Let's show how it's done. So this is the whole structure of our code. The first one includes the backend. The backend includes all the node modules which we require the node packages in this project. The second one is the routes, which contains the ambulance.js routes and the doctor.js routes. The ambulance.js routes includes adding the patients, and the doctor.js routes includes fetching the patients from the database and injecting the medicine. The services file, the service folder, I will talk about it later. The server.js combines the ambulance.js and the doctor.js. Now moving to the front end. The front end includes the node modules which we require in this project. The SRC folder includes the components, mainly the ambulance dashboard and the doctor dashboard. The ambulance dashboard shows how the ambulance page will look like, and the doctor dashboard will give us the look how the doctor will inject the medicine to the patients. The app.jsx merges all the ambulance dashboard.jsx file and the doctor dashboard.jsx file. Now I'll run the code. I have written the commands of backend and frontend for running the code, and now I will locally host it. So this is the main UI of the project. This is the doctor portal. It is getting refreshing. So these are the members. These are the patients coming. I have already added in the database. This is the information of the patient that the ambulance has added. Now the doctor will choose the medicine. This is the dummy medicine I have added into the database. The doctor can add or subtract the dosage, and it will inject. I, Rishabh Sandy.
Hi, Princess. Today we are explaining you about hardware components that we are using in our project. Let's see them. First of all, we are using lithium-ion batteries that are nominally rated for 3.7 volts. We are using two batteries in series, providing us 7.4 volts. But our most of the components required 5 volt. So we are using buck converters that will convert our 7.4 voltage to stable 5 volt. Then we are using our 4G module, that is Simcom A7672S. It is for providing wireless connectivity between the doctor portal and our hardware components. We have also connected antenna that is using ULF connector.
Now let's come to the microcontroller part, which is Raspberry Pi 4, 4 GB RAM, and 64 GB external storage that is being provided through SD card, and in which operating system was installed. Let's come to the power input, which is being provided by the Raspberry Pi official adapter of 5 volt 3 amps to power the Raspberry Pi for the stable working. The main function of Raspberry Pi is to do all the computation part of the command that is coming from the doctor portal through 4G module and getting stored at 4G module, which is then accessed by Raspberry Pi through 80 commands and decoded by the Raspberry Pi for providing the instructions to our unipolar stepper motors that are driving our peristaltic pump through motor drivers ULN 2003A to providing the commands to ULN 2003A. So now the doctor will be injecting the medicine. So I'll choose a random medicine and put dosage 0.5 ml. And I'll get inject medicine. The medicine has been injected and the message is being shown on the 4G module. The message is being shown.
Now the water will start dripping from here, and as you can see, it would be 0.5 ml only. We will show you the end result. I think the water has flowed, and as you can see, it's exactly 0.5 ml. Now, after pressing the inject button, we would go to a Raspberry Pi terminal and it will show that the message has been received and it is injecting dopamine 0.5 ml. This particular command is passed using Python programming language and is inbuilt in the Raspberry Pi, which we have downloaded. Now, the command will send itself to the 4G module using a modem. It will send now to the Raspberry Pi. Now, the Raspberry Pi will receive the command and parse all the commands using Python, which will further send it to the motor drivers here connected and which are connected to motors inside, which are peristaltic pumps. So after that, our workflow will begin and our medicine would start to flow. And after our medicine will start flow, it will exactly fill up to 0.5 ml as commanded. Okay, so now the hardware has been established and the software has also been set up and the communication between two has been set up and our motors are working perfectly and are pumping water. So you are wondering how the calibration has been established and that will be explained further by through. Mathematical model for this works in such a way that basically at first we try to fill all the data that after if we fill 0.5 ml how much we are actually receiving, and at the gap of 0.2525 we calculated all the data points and all the results that we are getting, and after getting the results and versus what we actually should get, we created a polynomial function using the AI so that we can calibrate and we can minimize the error that we are getting to achieve the precision that we want. So after using the AI function, we achieved the precision that we wanted. And now all the model has been explained by my team partners. So in the future scope, we can also implement Python automation tools to automate all the manual stuff that we need to do.
Now, for designing the structural part of a model, we first need to think about what different things we need to design at the very end. For example, we need, of course, need 4 medicinal hoppers that will store different medicine, out of which the doctor will choose which medicine to pick according to the needs of the patient. After that, a main enclosure or housing of this model is needed that will store all the components of the model and also provide structural strength. And at last, as we know that we need to dispense about precise amounts of medicine, and also there should be no risk of impurity. So instead of valves like pinch valves or solenoid valves, we will be using peristaltic motor. This is because peristaltic motor does not have any contact with the fluid, and moreover, it also dispenses liquid very slowly so that we can guarantee that the liquid is dispensed in very precise amounts. And after this, we will show one designing different CAD models.
As discussed earlier, this is a 3D hopping model, medical model, which has 4 cylindrical containers. Each stores medicine, and below these model, you can see there are four conical structures which are used for dispensing the liquid, and this whole hopping model is placed on a housing structure. This structure has enough area and dimension for the placement of the hopping model and has an inclination on the floor which increases the efficiency of our dispensing.